Even and odd functions. Functions with symmetry with respect to the y-axis are called even functions. Functions with symmetry with respect to the origin are called odd functions. Notice that we're not talking here anymore about x-axis symmetry because anything with x-axis symmetry cannot be a function because it automatically will not pass the vertical line test. So the only two types of symmetry that we can have with functions are y-axis and origin, and we call them even and odd functions. Now, you can use the test we talked about. Y-axis symmetry you test by putting in a negative x and seeing if you get the same function. For the origin, you put in a negative x and a negative y and see if you get the same function as you originally had. Or, as long as you have nice polynomials, you can say, well, if all of them are even powers for our x's, then it should be even. If they're all odd powers, that should be odd. So looking at A, we have x to the fifth, x to the third, x to the first. This should be an odd function. So let's go ahead and think about that test now. Since it's odd and we know it's symmetry about the origin, that means if we put in a negative for y and a negative for all the x's, we should end up with our original function. Okay, well, the thing is that with odd powers, each of these things changes signs. So negative y equals negative 3x to the fifth, positive 2x to the third, minus 4x. So all of our signs have changed on the right. And to get rid of the negative that's in front of y, we would change them all back, giving us our original function. So see, it really is odd. If they all have even powers, then it should be even, so that's what this next one should be. But the tricky thing is this number, negative 1, the way it works is that it's like there's an x to the 0 power. X to the 0 is just 1, so it goes away, we don't write it, but that 0 power means it still has an even power. So this will be even, but let's test it. So put in negatives for our x's. And so you can see that the negatives will go away because of our even powers, leaving us with exactly what we had to start off with.